Okay, so we are now going to see the installation of ISOD HRP impact tester. When the user will receive the equipment, it will always be in one piece and the pendulum will be tied up at the bottom along with the vise. The equipment will be supplied with a communication cable, as you can see here. It's a USB to serial converter along with the equipment that we are going to offer you. And you have to install the driver of this USB to serial converter along with the software that is given to you. This is a equipment designed as per ASTM D256 for ISOD, ASTM D6110 for HRP, as well as ISO 179 for HRP and ISO 180 for ISOD. So we will see what all comes with the equipment. The pendulum that is being fixed, this is a R1 pendulum as per ASTM D256, and we have offered you R2 plates, R3 plates, R4 and R5 plates to convert right up to 25 joule. Along with that, we have offered you the HRP pendulum, the HRP vise. There is a separate pendulum and vise as far as the ISO is concerned. So we have given you one bigger vise that will take care of 229 mm pendulum as well as 394 mm pendulum for HRP as per ISO 179. If you look at all these attachments, you will come to know that HRP specimen in case of ASTM is 127 mm, but the same is 80 mm in case of ISO. So even the attachments of R1, R2, R3, R4 are different in case of different. Now these bigger pendulums that you can see is offered especially when you are going up to 50 joules. So this is a big pendulum as per ISOD, and this is a HRP 50 joule pendulum that we specifically offer when the customer wants to go for the bigger capacity machine. The standard equipment that we are offering you will come up to 25 joule capacity with all these attachments. So when you receive the equipment, first you ensure that the power supply 230 volt single phase is stable within 5 volt plus minus accuracy, and then you power on the equipment. When we power on the equipment, it will be always in the auto mode, as you can see here. In auto mode, when you release by pressing enter, the pendulum will release and you will be able to see the results over here in all the units on the right hand side of the controller. There are LEDs indicating the values like joule per meter, kg cm per cm, kg meter per meter, joule per mm square, joule per cm square and kilojoule per meter square. The way you go on scrolling, the upper and the lower LEDs will represent the upper and the lower values that will be seen in the result. So this is how you can use the equipment standalone even without using a software. At the bottom, if we go, we will see a stick plate that is being offered for guiding the specimen when you want to fix the specimen. So I will show you how we fix the specimen. There is a notch that will go from the center. So you see there is a center guiding plate that will ensure that the axis of the notch is exactly at the center of the vise. We offer you one torque meter where you can adjust the torque between 3 to 5.4 Newton meter based on the different rigidity of the materials, and this is very essential to ensure that a constant force is applied on the specimen every time when you take a trial. Now coming to the software. So the equipment is connected with the cable, and then you come to the software and you open the software. you have to feed the username and password. The username is IZOD and password is enter. So when you see the home page of the software, we haven't done anything and it automatically got connected. This is the specialty of a Linux software, where it connects automatically. When it comes to know that a machine cable is connected and powered on, it will automatically connect. Only thing is that you have to install the USB to serial driver. Now on the software, you can go to settings, and in the settings, when you enter inside, you can feed all the required data. Now normally the required data relates with the customer name, address, material, everything you can feed. And here you can go and select the kind of test you want to do, whether it is IZOD or whether it is Charpy. So first thing the user does is, user will select the test and user will select the scale. Now it is very important for the user to note that the scale selection should match with the pendulum that you are using here. Now how the pendulum is referred with respect to scale, that we are going to see. So this is the R1 pendulum of IZOD. When you want to convert this R1 into R2, you have to use the R2 plates. So we are now going to see how to convert R1 into R2 by fixing these two plates. So we will take these plates now. Now we have taken the R2 plates, and as you can see, the bolts have been fixed inside out. This is very important for the user to note, that the bolts have been fixed inside out. Why the bolts have been fixed inside out? Because the threading is on the plate. So you put the bolts from here and you fix it up with the plate, two plates on two sides to maintain the symmetry of the pendulum. Now R2, why do we use R2? As per the ASTM standard, you have to always select a scale that will show the result that is between 15 to 85% of the referred scale. For example, the R1 scale, when you use a single pendulum, the capacity is 2.71 joules. So if your sample breaks at a energy beyond 85% of 2.71 joule, which may be approximately 2.3 plus, then the standard says you have to shift to the scale 2. So the way we have fixed these plates, it is very important. The bottom side is longer, the upper side is shorter, and this is how you have to fix the plate. And you select R2 on the software so as to get the right energy and the value. Now as per the specimen, I am talking about ASTM D256. So the length of the specimen is 63.5 mm. The width of the specimen is 10.16. Many people make a mistake over here. They simply make a notch of 2.54 as per ASTM D256, which is not right. You have to actually measure the width of the sample, and the notch should be decided based on the fact that the remaining width of the specimen after notch should be 10.16 mm, because the result depends on the remaining width of the sample and not the notch that is cut off. So you feed the data, you feed the specimen thickness. Normally in India, people moreover refer with a thickness of 3.2 mm. So I have fed 3.2 mm, and you simply save the data. Once the data is saved, it will appear here on the front page of the software, and you are ready to conduct a trial. So we'll show you how the trial is being conducted. I'll take a long view. So now we have fixed up the sample at the bottom, and we are going to see the trial. So R2 pendulum, R2 scale is being selected, and once the start command is given from the software, now our engineer will give a start command and the pendulum will release. You will be able to see all the results. So as soon as you give a start command, the controller will flash, pendulum will break the sample, and you will be able to see the results even over here in all the units of joule per meter, kg cm per cm, then kg meter per meter, joule per mm square, joule per cm square, and kilojoule per meter square. All the results can be seen here on the software, and we are going to offer you a manual along with the equipment that will show you all the features of the software. So all the units you are able to see the result as per ASTM standard as well as IS and ISO standard. You simply take a printout. So this is how the whole equipment works. Now first we have seen the fitting related to the ISOD. So now we are going to see how the Charpy fitting is to be done. In case of Charpy, we are going to remove this ISOD vise. We are going to remove this ISOD pendulum. Now the plates R2, R3, R4 and R5 are common when it comes to the ASTM standard. As I said earlier, in case of ISO, these will be different, and why these are different, that we are going to see further in the video when we fix up the ISO specification vise and the pendulum. So now we will see Charpy. Now this Charpy, what we are seeing is as per ASTM. So in case of ASTM, what we do is this pendulum rod will remain the same, and the upper part, the hammer you call it, will be replaced. The ISOD we have removed and Charpy we have fixed here. Same way we have removed the ISOD vise and we have fixed the Charpy vise. So in short, the difference between ISOD and Charpy is, as you might have seen earlier, the ISOD specimen was placed vertically, fixed at one end, and Charpy sample is placed horizontally, guided with two supports. So this is going to be a vertical impact. In case of ISOD, it was a horizontal impact. So what user has to only understand is how to fix the Charpy in case of ASTM, as well as further we will see how to fix it up in case of ISO. There is a difference between ASTM and ISO which I am going to explain you now. Before that, we will at least see how the specimen breaks and how we are going to select. So this is R1, R2, R3, R4 plates are common in case of ISOD and Charpy ASTM. So we'll give a start now by selecting Charpy. We will again go to the test setting, and here we will select a Charpy with R1. Now R1 scale. So this is very, very important. We are going to select R1. We feed the data. So 100 mm is the specimen. Length of the specimen is 100 mm. I mean support span is 100 mm. You have to feed the support span. Then the width is 10.16. Thickness is the same. You simply save the data. And after saving the data, you give a start command. So as soon as you give a start command, again the pendulum will release, the specimen will break, and same like ISOD, you will be able to see all the results on the display. So the procedure of ISOD and Charpy is same. User has to only understand how to change the fixtures. The difference between ISOD and Charpy, as explained earlier, same way we are further explaining you the difference between ASTM Charpy and ISO Charpy. ASTM Charpy all the same common plates R2, R3, R4, R5 will be fixed. And how these should be fixed, I am showing you now. The way we have fixed the plate on ISOD, in this case, we have to remove the hammer. We will use a spanner, remove the hammer, because in this case, one plate will be towards the rod inside and one will be at the bottom. We will show you very quickly how it is to be fixed. So we have removed this, fixed the plates on two sides, because you have to remove the hammer and fix it up. Okay, so now you can see one plate, again the bolts are from inside out. One plate is at the bottom and one plate is on the top. You bring it down, so we will show you how actually it is fixed and how it will work. Okay, so this is R2 plate that we have fixed on R1 pendulum, R1 hammer of Charpy, to make it a double capacity, that is 2.71 has become 5.42 now, and we go on incrementing up to 25 joule in the same fashion as far as the ASTM is concerned. In case of ISO Charpy, there is a difference, so we will come to that now. By replacing it with a bigger vise, we are going to use a bigger vise, and we are going to use the two smaller and bigger pendulums in case of ISO 179. So this we are going to show you one by one. So now you can see we have removed the ASTM Charpy and we have fixed the ISO vise. Now you can see we have provided two slots. What is the reason to provide you two slots? The difference in case of ISO 179 is there are some specific energies and pendulum lengths. For example, you need to have the R1, that is 2.71 joule and 5.42 joule, the double of it will be with 2.9 meter per second velocity. So we have to offer you a pendulum of 229 mm. So this is R1 pendulum, you bring it down. When you bring it down, you will see the height of this pendulum is 229 mm. So the upper slot of the vise will be used for conducting the trial. Now when you want to convert it into R2, as I said, the two plates are given and they should be fixed in the same manner as we have shown you in case of Charpy, but these two plates are for ISO, they are separate from the one we have offered for ASTM. Same way we will show you when you have to go beyond 5.42 joules, you have to use a 394 mm length big pendulum, removing this 229 mm pendulum. So we'll remove it now and fix up the 394 mm pendulum, for which the lower slot is offered for you to place the sample for energies beyond 5.42 joules. So in short, the R1 pendulum 229 will have 2.71 joules. When you attach these two plates, it will become R2 with 5.42 joules, and then directly R3 will be a bigger pendulum of 394, and when you attach two plates R4 on 394, it becomes R4 scale, that is 21.68 joules. So this is how the chronological order goes about ISO. Now you see we have placed the sample at the bottom and we will be fixing the bigger pendulum of Charpy for conducting any trial that will be beyond 5.42 joules, so that it is aligned with the lower slot. The major difference to offer you different vises in case of ASTM and ISO is due to the length of the pendulum as well as the span length. In case of ISO is 64 mm, which is otherwise 100 mm in case of ASTM. So this is how we complete the trial and demonstration of the ASTM and ISO equipment. Now, as per the user, we offer both the capacities. ASTM we offer ISO ASTM together. So user may be receiving all these attachments based on what they have ordered, and the bigger attachments in case if they go up to 50 joule. Of course, the machine will be more sturdy when you go for 50 joule capacity, but the operation and the working being common, we have covered up everything in one particular video. So now we have fixed this long pendulum. You can see this is for the slot of 394, where the striking velocity of the pendulum is 3.8 meter per second. So we will conduct one trial now to see the result. Okay, we have just placed one sample. So we are selecting R3 scale in Charpy now as per the ISO standard, and we will feed the dimension. The span length will be 64 mm, and in case of Charpy it is 10 mm sample, so we feed 8 mm because the notch will be 2 mm and the thickness will be 4 mm. These are fixed dimensions, so you save the data, and once you have saved the data, you will simply go and give a release command from the software to see all the results on the display of the controller as well as on the software. So in short, we complete the ISO, Charpy, ASTM, ISO. Thank you so much.